Good day. In this video, I'm going to show you how to work out the general solution with a shortcut on trig equations. Because I don't like this technique, I will not be using it in any of my other videos. Please look at the other video that says general solution in trigonometry. It's much easier. Because some textbooks only explain this technique, some teachers contacted me and asked me to make this video. Here we go. Now on this page, you can see a summary of the general solutions. According to me, there are 5 sets of solutions. The sine ratio uses both these sets, the cos both these sets, and tan only one set. All the number 1 sets are basically the same. Only difference here is a 360, and here's a 180 at the tan. Don't get afraid of the big words now. If we get the ratio sine theta, we want the size of this angle equals to a certain ratio, any value. That value must lie between -1 and 1, otherwise it won't work. It also include the -1 and the 1. You will then find the general solution by writing the size of the angle equals shift sine of that ratio plus K360, or that angle will be 180 minus shift sine of that value plus K360. These two general solutions will get you to your answer. Don't be upset, we'll do an example of each ratio now. If you get a trig equation with cos theta equals to a certain ratio, and that ratio lies between -1 and 1, including the -1 and the 1, then your general solution will be that theta equals to plus shift cos of that ratio plus K360, or theta equals to minus shift cos of that ratio plus K360. And remember to write at the back of your general solution, K is an element of Z every time. If you get a trig equation with tan theta equals to a certain ratio, that ratio can be any number, positive or negative. There's no limitation. Then that theta will be equal to shift tan of that ratio that you had plus K180. Remember, K is an element of Z. I'm not going to spend a lot of time on this K360 and K180, but in short it means after you get your shift sine of this ratio and you get an angle, that'll be one of your answers. And then every 360 degrees further on, plus 1 360, plus 2 360, you'll get the same degrees that'll give you the same ratio as you had here. But don't break your head about that. The same will apply to cos. Every 360 degrees down the line, you'll find the same ratio for those degrees. And just at tan, there will be the same answer every 180 degrees. But don't break your head on that either. Now we're going to do one sine equation, one cos equation, and one tan equation. You must know these two sets of general solution sort of formulas. And remember to put this thing in a bracket of its own. So we're going to take this minus a half and put it in the place of this e, and take this minus a half and put it in the place of this e, in all those extra brackets, please. So this part, your first step will look like this for this equation. Remember, this is not supposed to be here, it's just to remind you what to do. Then you'll push this into your calculator, you'll type it in, you'll go shift sine, it'll give you a bracket immediately, minus a half, close the bracket, equal. Please remember to write here, K is element of Z from our, let's call it formula. Then you'll have this answer. Now you have the first half of your answer, A equals to minus 30 degrees plus K360, K is element of Z. Then you take this second part of your formula, let's call it a formula, you write it down, you replace the minus a half in the place of that E, remember it over there, then you're ready to work it out. Then your expression will look like this, and you simplify that further. Then for your second part, the answer is A equals to 210 degrees plus K360, K is the element of Z. So we have two parts now, 1, 2. Together they give us the general solution of this equation. Then your final combined answer will be A is equal to minus 30 degrees plus K360, or A equals to 210 degrees plus K360, K is the element of Z. And there's your final general solution of this equation. Now you might get a general solution as an answer in some cases where they give you this combined with that, and that is the same as what we had originally. This top one and this second one is the same thing. After you've done reduction, you will understand that minus 30 degrees is the same as 330 degrees, but that's not the purpose of this video. Please stop the video and try to understand how we got from this equation to this general solution through these two formulae. Now we're going to do a cos equation. I'm going to go a little bit faster because we're now used to it. You know your two, let's call it formulae, that go with the cos equations. They are the angle equals to plus shift cos of the ratio plus K360, or the angle is minus shift cos of the ratio plus K360, K is the element of Z. All we do is we plug that plus a half in the place of E there and there, but we work them out separately. You write this down from your knowledge here. Plug in the calculator, shift cos plus a half, close the bracket. Then you get plus 60 degrees plus K360. The first part of your solution is B equals to 60 degrees plus K360, K is the element of Z. Half of our work done. Then we go or, and we take the second part of our formula and plug that plus a half in the place of that E. So we write minus bracket, shift cos of the half, close the bracket. Then we work this out with your calculator. Remember to keep this in its own bracket with a minus outside. Then we'll get this. Simplify it, and the second part of our solution will be B is equal to minus 60 degrees plus K360, K is the element of Z. Combining the two parts now, my final answer will be B is equal to 60 degrees plus K360, or B is equal to minus 60 degrees plus K360, K is an element of Z. And like I said previously, you might find a memo that gives you this and this as the general solution combined. But this you'll only understand after you've done the reduction. Minus 60 degrees is the same as 300 degrees. So for now, here is our general solution to this cos equation. Stop the video and get your brain around this. The last sum of this video is a tan equation that gave us tan theta equals to minus 1. We have our sort of formula that we're going to use. I'm going to plug that minus 1 in the place of that E there. So the general solution starts off like this. Theta equals to shift tan of minus 1 plus K180. K is the element of Z. Remember, only in tan do we write the K180 here. It's 360 in the other two. Now you type into your calculator, shift tan of minus 1 equals. Then you will write theta equals to minus 45 degrees plus K180. K is the element of Z. And take note, tan has only one piece of a solution, where the other two ratios had two pieces of a solution. And if you see a memo that says 135 degrees plus K180, you can know it's the same as our answer. Please stop the video and get your brain around this. Now let me quickly explain what this general solution here says. It says that if I push tan minus 45 degrees into a calculator, I will get minus 1. And if I push tan of any number which is minus 45 plus or minus 180 degrees, it'll get me also a minus 1. So I took here some examples. I took the minus 45 plus minus 1 times 180 gave me minus 225. I plugged in the calculator, tan minus 225, it gave me a minus 1. Please check it. Then if you take minus 45 degrees plus no 180s, that gives you minus 45 degrees. Plug it into the calculator, it'll give me a minus 1 as my ratio. And I can do many more. Minus 45 plus 1 times 180 gives me 135 degrees. Tan of 135 degrees gives me minus 1. It's a general solution for all the answers for a ratio of minus 1 for tan theta. So this rear part is important. I can use any integer, plug it in here, work this out, and it'll give me minus 1. Please indicate whether you liked or disliked the video and subscribe to the channel. Enjoy general solution.